Here are solutions to perfect problem 6. I might have gone a little bit overboard with this one, but we'll see how this goes. I'm just asking you one question. I mean, it's a short question. I'm just saying find the derivative of this thing. Turns out that is quite the derivative to take. What you'll want to do is use what's called logarithmic differentiation. So you're first going to set this up as an equation. It'll be y equals all this stuff. And you can be really careful with the parentheses here. It's x raised up to the x power. And that entire thing is raised up to x to the x raised up to the x. Good Lord. There are some rules you can do when you have exponents raised up to exponents. I think you could rewrite this one as x raised up to the x squared if you want. I'm not even going to bother with that. You can if you feel like it. You don't need to. Really, what you're going to do is you're going to try to get the x's out of the exponent. And the way you're going to get the x's out of the exponent is by introducing logs. Hence logarithmic differentiation. If y equals this whole mess, then the natural log of y must be equal to the natural log of this mess. X raised up to the x power. Maybe color coding would help a little bit here. Raised up to the x power raised up to the x. Note that what I now have is the natural log of something in green here raised up to some other exponent in red here. Now, so you can use your third log rule to move this thing in front of this log. What I'm saying is we could rewrite this. We could say the natural log of y is equal to, and then this entire thing that I had in red, which was x to the x raised up to the x power, times the natural log of x raised up to the x power. Something like that. And it turns out that, I wonder if I should have done that in a different color. Well, I'll leave it for now. It turns out you can use another log rule here. And the way I'm going to do that is in this first one in red, there's not a whole lot I can do. I got x raised up to the x power raised up to the x power. But over here in green, I'm taking the natural log of something, and it's x raised up to the x power. So note that I could use the third log rule here to take this thing in blue in front of this natural log. What that would give me is that the natural log of y would be equal to, in red, x to the x raised up to the x. And then in blue, x to the x. And then in green, the natural log of x. Wow. Okay. Good news is this isn't nearly as big of a tower as it used to be. Bad news is you still got some stuff up in exponents. You can't go taking the derivative of both sides just yet. Okay. Well, how am I going to get these things out of the exponent? This x right here is bad. I got two x's over here. That's even worse. Let's take the natural log of both sides of the equation. Okay. So I have the natural log of y. And that's equal to the natural log of something, x to the x raised up to the x, times something else, x to the x, times something else, the natural log of x. So where can you go from here? Well, on the right-hand side here, I have the log of a product of three things. And there's a log rule that says if you're taking the log of something times something, you can rewrite it as the log of something plus the log of something else. You can break up the log of a product into the sum of logs. So I'm going to leave the left side alone, natural log of the natural log of y. But on the right side here, I'm going to use my first log rule to rewrite this as the natural log of x to the x raised up to the x plus the natural log of x raised up to the x plus the natural log of the natural log of x. Wow. Okay, it continues. Over here on the left, I'm leaving this alone again. Maybe I should just, well, guess I can write it out every single time. But over here on the right, I think I'm missing parentheses somewhere. It's the natural log of that stuff. So in red right here, I have an exponent raised up to an exponent. My base is this x to the x thing, and my exponent is this x right here. So I can take this x and bring it in front of this natural log to get x times the natural log of x raised up to the x power. And then to that I can add, I can use that same idea here. I have an x up in the exponent, so I can bring it down in front. And then I got the natural log. I think my color scheme here is getting a little bit arbitrary, but I'll try my best. And then finally to that I want to add the natural log of x. I'm almost done. Over here I have the natural log of something raised up to an exponent. So the natural log of something raised up to an exponent, I can take that exponent and bring it down in front. I can say that I have the natural log of y, and that's equal to, I got this x still, but then I also have this x times the natural log of x, plus x times the natural log of x, plus the natural log of the natural log of x. I think at this point I don't even need color coordination. Note I haven't done any calculus yet. This is a calculus class. You're going to be doing calculus. But we haven't even needed any yet. X times x is x squared. By the time I've applied all my different log rules, I get down to this equation here. This is where I'm finally going to do some calculus. I know you've been waiting. This is the calculus step. I'm going to take the derivative of both sides of the equation with a whole lot of chain rules. The derivative of the natural log of something is 1 over that something. That something in this case is the natural log of y. So I'm not done. I have to multiply by the derivative of the inside function here, the natural log of y. The derivative of natural log of y is 1 over y times y prime, because y is a function, not a variable. So that's a chain rule inside of a chain rule there. On the right-hand side, I got x squared times the natural log of x. That's a product rule. The derivative of the first thing, x squared, is 2x. Leave the second thing alone. And then to that, add the second thing left alone, x squared, times the derivative of the first thing. So you get this mess. And then to that, add, so this is a first product rule. Second product rule, x times the natural log of x. We'll take the derivative of x, you get 1 times the natural log of x, plus the derivative of natural log of x times x. That was this one. And then finally, this last one, I got the natural log of the natural log of x. So that's 1 over the natural log of x times 1 over x for a chain rule. That was my calculus step. Now I just got to clean this thing up. Let's see. I'll leave this left side for a minute. Maybe I'll clean it up a little bit. I got y prime over y times the natural log of y. And that's equal to 2x natural log of x plus x, because 1 over x times x squared is just x, plus the natural log of x plus 1 plus 1 over x natural log of x. 1 over x is just 1. 1 over natural log of x times 1 over x is this thing right here. Now if I multiply both sides by y times the natural log of y, I would get that y prime is equal to y times the natural log of y times 2x natural log of x plus natural log of x plus 1 over x natural log of x. Alright, and this won't serve as my final answer because this has y's in it. And y is just this thing I invented here. It's just taking the place of all this stuff. So really, everywhere you see a y, you should change it into this thing, because in the original question there weren't any y's. So I got to rewrite this thing, except in place of this y and this y, I write all this stuff. So maybe up here? Got a little bit of real estate up here. Okay, so this derivative is equal to this. Instead of y, I'll write this stuff. This stuff is x raised up to the x power. And that entire thing is raised up to x to the x raised up to the x. This right here is y. I want to multiply that by the natural log of y. Again, y is x raised up to the x to the x raised up to x to the x raised up to the x. And then that whole thing gets multiplied by 2x natural log of x plus natural log of x plus 1 plus 1 over x natural log of x. Wow. If you felt like it, and frankly I don't, you could apply a log rule right here. This is the natural log of this stuff raised up to this power. Just like down here, this thing in blue is the exact same as this thing in red and green. And this thing in red and green I rewrote like this. So if you felt like it, you could do all sorts of simplifications to this. Could simplify more, ... but I won't. I think I'm going to go ahead and call this good. Maybe throw a box around it. Something that looks something like a box. And call that crazy problem done.